Hello friends, in this one I'm going to show you how to find the value of negative I raised to the positive I. So the first stage is to rewrite this negative I to the positive I as e to the ln of negative I times I. And the reason is that there's a basic rule that states the following, that a complex number z raised to some power c is equivalently written as e to the ln of z times c. The reason is that the ae and the ln functions are inverses, so I could just cancel them off and get back to z as the base. This is pretty much the same property as exists for real numbers like 5 or 10. Keep that in mind. So I'm going to rewrite at step number 2 as e to the ln of negative I times I. Now what we have to do is work out the value of ln of negative I. Let's go through that process. So I'm going to find the value of ln of negative I for that reason. I'm going to convert negative I to its exponential form as follows. I have here a picture. Now in this picture at step 4, the vertical axis is the imaginary axis, the horizontal axis is the real axis. So then to represent this number negative I imagine basically swinging through a negative pi over 2 radian turn this way, and there is negative I in that position. Now at this negative I, the magnitude, if you like, of that number, which is what you need for the exponential form, well, that's just 1 unit. That's just going from there straight down to here, you see? So that's 1. And the angle that it makes with respect to the positive horizontal axis here is negative pi over 2. So what it says basically is that negative I is equivalently written as 1 times e to the negative I pi over 2 for that reason. I'm going to use this exponential form of the number as follows down below. So over here below me, I'm going to find the ln of negative I as the first step. Unfortunately, that L there got a little bit cut off, but it's present. So it's supposed to say ln of negative I. So I'm going to replace negative I with this quantity. So in other words, it's going to be ln of 1 times e raised to the negative I pi over 2. I make that replacement as a first step because these are interchangeable, different representations of the same quantity. But this form is more useful because then you see that the 1 is multiplying the e to the negative I pi over 2. So I can write it by a basic property of logarithms, even for complex numbers, as ln of 1 plus ln of e to the negative I pi over 2, you see? Now the part that's ln of 1, that's just the ln of 1, the natural log of 1, the usual way. That value is just 0. But for this part, ln of e to the negative I pi over 2, that can be replaced directly with negative I pi over 2. And the reason is that, remember, the ln and the e functions are inverses. So basically they cancel off, and you just bring that negative I pi over 2 straight down here to the same level as the 0 above my head there, okay? Slightly above my head. And then of course the 0 part goes away, so you are left at the end with negative I times pi over 2. So all of this work is required just to convert negative I to this exponential form, and then to find the ln of negative I as this value right here, because now what I can do is this. Go back to step 6 right here across the top, and whereas before back at step 2 I had e to the ln of negative I, now I'm going to replace ln of negative I with negative I times pi over 2, and there's also a pi left over in a position above my head. That is that I is the same as this I right here, back at step 2. So there are two separate I's. One is negative, one is positive. One is in the ln function, one is completely outside it. So that's why back at step 6 it looks as shown here. So then what I can do is I can take negative I and multiply by positive I. That's going to give me negative I squared times pi over 2. Close now. Negative I squared, that's going to become negative of negative 1. The reason again is that I squared is replaced with negative 1. So it ends up being the negative of negative 1 of pi over 2. And of course, the negatives multiply and you end up at the last step, step number 9, with e to the pi over 2 positive, and that is the final answer. And that is it for this rabbit hole in a complex analysis. Thank you so much. I hope it's been insightful. Please leave a like and subscribe, and I will see you in another video.